If alpha beta are the two roots of a quadratic equation, 2x square minus 3x minus 5 is equal to 0. Find the quadratic equation whose roots are alpha square and beta square. Now, over here, if we compare the given quadratic equation with the standard form, we will get A is equal to 2, B is equal to minus 3, and C is equal to minus 5. Now, AC is equal to minus 10. And now we want to factorize minus 10 in such a way that the addition of factors comes out to be minus 3. Now, coincidentally, we can see it immediately that 2 plus minus 5 is also minus 3. So therefore, we will directly use this as the factors itself. So we'll split the middle term as 2 and minus 5. So we will have here 2x square plus 2x minus 5x minus 5 is equal to 0. So taking 2x common, we will have here x plus 1, and taking minus 5 common, we will have here again x plus 1 is equal to 0. So therefore 2x minus 5 multiplied by x plus 1 is equal to 0. So therefore x could be either 5 by 2 or x could be minus 1. So we can say that this is alpha is equal to 5 by 2 and beta is equal to minus 1. Now we want the quadratic equation whose roots are alpha square and beta square. So alpha square will be 5 upon 2 whole square, that is 25 upon 4, and beta square will be 1. Now to get a quadratic equation from roots, the standard form is x square minus sum of roots into x plus product of roots is equal to 0. So let's find out the sum of roots here. So alpha square plus beta square is equal to 25 upon 4 plus 1. So it comes out to be 29 upon 4. And product of roots, that means alpha square and beta square, that comes out to be 25 upon 4 multiplied by 1, that is 25 upon 4 itself. So therefore, substituting these values in this equation, we will have x square minus 29 upon 4x plus 25 upon 4 is equal to 0. Multiplying throughout by 4, we will have the final quadratic equation as 4x square minus 29x plus 25 is equal to 0.